Welcome to tutorial 3 of circular or rotational motion or circular motion. So the first one says a belt runs on a wheel of radius 44 centimeters. During the time, the wheel takes to coast uniformly to rest from an initial speed of 1.6 revolutions per second. Then they are saying 29.5 meters of the belt length passes over the wheel. Find the deceleration of the wheel and the number of revolutions it turns while stopping. All right, so you can pick whichever you want to start with. It is up to you actually. So let's look at question 1, solutions. All right, let's look at the data that we have. Okay, we have a radius of the wheel, which is 44 centimeters, which just is same as 0.44 meters. We have the angular speed. The first one is the initial, is 1.6 revolutions per second. We also have the length of the belt. We call it S, just equal to 29.5 meters. This is what we have. So we can choose whichever one to start with. Let me start with the first thing. Let me start with the number of revolutions. Number of revolutions. So to find the number of revolutions, we know that the length of the wheel, what we have is like this. Then this is the radius, the one we are calling R. Then there's a belt, okay, which is passing through, and that belt is 29.5. So that belt is passing through this circular wheel here. The wheel of the radius is the radius of the wheel is actually 0.44 meters. So what we need is the angle of rotation, that which is just the angular displacement. So we know that it is related by this formula. All right. So to find this, we are saying this is S over R, and S is 29.5 meters, while R is 0.44 meters, and this will give us 67, yes, 67.04. Of what has been given here, we can just round it off to the same number, rad. The same one is also just equal to this, but so for us to find it like this, we just need to know how to convert rads into revolutions. And we know that if we've got our if you've got our 67 rads, we need to multiply by 1 revolution, which is equal to 2 pi rad. Considering that and that will give us 10.7 revolutions. Okay. All right, now we can now go on and find the deceleration. Because it is going uniformly to rest, it means it is implying that the constant angular, they are implying constant angular deceleration. So you know the equations of motion. Now the equation of motion, when you bring them into the angular aspect, there's this equation that we use. Do you recall this? V squared is equal to U squared plus 2AS. You remember this equation? Now in angular, or let me say rotational motion, this velocity is given by this. So this one will be our final is equal to squared initial plus 2 acceleration. In this case, it will be our angular acceleration. Then our S, it will be our S. In this case, it is the angular displacement, theta, like that. All right, now the final one will always be 0 because it is going to rest. And the initial one, the initial that we have is 1.6. We square it, so 1.6 squared plus 2. Angular acceleration is what we are looking for, so is angular chain. Then theta in this case is what? What is our theta? Theta, we actually just found it. It is here. You can use the 10.7 revolutions. So get your calculator. So if you square this one, So 1.6 squared, we are getting 2.56 plus, let's come here. So this one will give us direct in the units that we want, which is the revolutions per second squared. So if we get this one and put there, it means later on we need to take into consideration that we need to convert those into revolutions. But we already have 4 revolutions. We can just use it direct, which will give us 21.4 angular acceleration. So this will be 21.4 angular acceleration is equal to negative 25, so 2.56 divided by that, dividing by that, we end up having angular acceleration. And because remember it's deceleration, so it is going to decrease, negative 0.1196 and so forth, of which what we have here is actually 0.12. You can clearly see that we can actually round it off to give us negative 0.12 revolutions per second squared. That is the answer. So question 1 done. Let's go to question 2. I'm going to erase this part. So question 2, so let's go now question 2, solutions. A carton of eggs sits on the horizontal seat of a car as the car rounds a 26-meter radius bend at 16.5 meters per second. What minimum coefficient of friction must exist between the cartoon and the seat? So the carton on the seat if the eggs are not to slip. Assume you're driving and this is a roundabout and this is your car and inside there are eggs. So they are saying for these eggs not to fall as you move around this circular path, what coefficient of friction must exist between the carton and the seat such that the eggs do not slip? So this is what we are going to find. Step 1 is that we need to relate what we call the centripetal force. We know that centripetal force is given by mass multiplied by velocity squared over radius, where r is just the radius there, all right, which has been given there, and the speed also has been given there, all right. So if we plug in everything there, what do we end up having? Right, so we need this relationship here, which I've written here. Okay, the friction force is equal to the coefficient of friction multiplied by what? The normal force. I hope the silence that was there, you were also writing something. All right, so this which we have here is the what we call is mu, which is the coefficient of friction force over normal force. Friction force, normal force is related by this with the weight of an object, which is mg. Now, in our case, the friction force is just the centripetal force. So, if we substitute it there, we end up having mu is equal to mv squared over r. All right, we are dividing by what? 1. So, we are dividing by mg. All right, so let's go. We end up having mv squared over r multiplied by 1 over mg. Mass and mass cancel out, so we end up remaining with what? V squared over rg. So we are saying our mu, which is the coefficient of friction, is just equal to velocity squared over radius multiplied by the gravity. All right, so the velocity has been given already as 16.5. We can just square that one over the radius has been given to be 26 meters, and well, gravity we are going to use 9.8. So let us punch everything here now. So if I punch on top here, I'm getting 272.25, and down here 9.8, I'm getting 254.8, which just be approximately 272, 254. 1.069. It doesn't have units because it is a ratio. So with what you've been given in the answer here, they have given us 1.07. I think you can see that it is a simple rounding off. So the coefficient of friction in this case will be equal to 1.07 as given by the answer there. So these two questions quite important. We'll keep on revising day by day.